0.5 is zeros of polynomial functions. And as we talk about zeros of polynomial functions, I don't know, we've talked about zeros on and off. You've probably talked about the vocab word zeros back in Algebra 1. Do you remember what a zero is? Okay, because this is something moving forward. This is one of those vocab words that I could see popping up in things like PSAT, SAT. At the time, I know ISTEP, I learned, it was a bit, it was a vocab word that would pop up there. And when we talk about a zero of a function is an x-intercept of the graph of the function. Okay? We also talked about zeros being solutions, but specifically, if it's a zero, it's going to be a part of the graph and cross the x-axis. Now, we're going to look at several pieces with that. First one is just being able to find zeros, and then being able to graph the function. And when I say graph the function, it's more of a sketch of the graph. Okay? So, just using the basics of what we know. So, as we look at A, what are the zeros of f of x equals x times x minus 4 times x plus 3? And then graph the function. Any thoughts of how to find the zeros?
I'll get 0 to x.
No?
Distribute the x first.
No?
No equation equal to 0.
Okay, so setting the equation equal to 0 means we're putting 0 not in for x, but 0 in for y, because f of x is another name for y, right? So that means we're putting, if it's an x-intercept, you're putting 0 in for y. And so setting that equation equal to 0, it's x times x minus 4 times x plus 3 equals 0. Now, this first one is already in factored form. How do we continue to find the solutions? If I have 3 factors, multiplying equals 0? No?
Set each factor equal to 0.
Yeah. This is where a lot of times we have 2 factors, we'll set each one equals 0. This time I actually have 3 factors. So we're going to set each piece equal to 0. So we're going to have x equals 0, x minus 4 equals 0, and x plus 3 equals 0. Okay? Solve those. One of our zeros is x equals 0. If it's x minus 4, what do you know? Yep. Add 4 to each side is your official thing, but then it's x equals 4. And if it's x plus 3 equals 0, subtract 3 and x equals negative 3. Those right there are your zeros. Okay? So in this case, we have 3 zeros. My graph is going to touch the x-axis in 3 places. So let's see, I'm trying to think of the order I want to do this in. So I'm going to leave room in the middle here to work yet, but if I start sketching a graph, and this is, not very fancy here, but x-axis and y-axis, right now, I know my graph is going to cross put some numbers on here. Okay. I know my graph is going to cross the x-axis at 0. I have a 0 at 4, so my graph is going to cross the x-axis at 4, and it's going to cross the x-axis at negative 3. Now, how does my graph cross all 3 of those places? Okay. And there's a couple of different ways we could do this. I'm going to go back to something we did in Unit 2, I think. Let's see, we're in Topic 3, so Topic 2, I think. But at the time, we set up a number line. And I don't know how much you remember about this. But we set up a number line trying to figure out which section of the graphs are positive and which section of the graphs are negatives. Okay, this is one way to talk about it. I have another way I can talk about it as well. But with this in mind, I don't need even spacing. I just need your numbers in order. So if I put these zeros in numerical order, I'm going to be at -3, 0, and 4. Okay. Notice I don't care the spacing. They're just numerical order. How do I figure out whether each section, each in between, is positive or negative?
7 something is less than the left -3, so -4.
Okay. So we're going to use test values, right? So over here to the left of -3, something smaller. I'm probably going to go with -4. You can go with whatever makes you happy, yes? Now, here's the nice part. Let's see. I use -4. We have factors right here, yes? All I need to know is this positive or negative? So plug this value into x and tell me what each of those factors are. So like when I plug -4 in for x, x is obviously going to have a negative value, yes? What about when I plug -4 into the middle parentheses? -4 minus 4 is going to give me what kind of value?
-8.
4 minus 4. 4 plus 5 is 8.
No. -4 minus 4 is going to be -4 plus -4, which is -8. Are we there yet?
You made that sound a lot more.
Just what is -4 minus 4?
There you go.
It's a negative, yes?
Yeah.
I hope I've sold you on that. I'm not sure I have. Sure. Okay. Put in -4 here. What do you know? What is -4 plus 3?
-1.
It's -1, so what I care about is it's a negative. What's a negative times a negative times a negative?
Negative.
3 negatives, an odd number of negatives always multiply to be a negative. So what I know about this piece of the graph right here is that it is a negative portion of the graph. Negative portion of the graph means it's going to start below the x-axis, right? Okay. What about -3 to 0? You can't plug in 0. I would love to plug in 0. What'd you say, Paul?
-4.
Okay. So basically your easy options are -1 or -2, aren't they? So if we use -1. Again, I don't need to know a numerical answer. Plug it into each factor. When you plug it into x, -1 makes x negative. What about -1 minus 4? That is a negative. And what about -1 plus 3?
2 positive.
That is positive. Negative times negative times positive.
Positive.
Negative times negative is a positive, right? An even number of negatives is a positive. And then positive times positive makes this section of the graph positive. Are you with me? Okay. What do you know between 0 and 4?
4, 3.
2.
1, 2, or 3 are pretty much your options, right? Pick one and test it. And here's the deal. I can pick 1, Kylie can pick 2, Paul can pick 3. We're all going to get the same answer. Okay? As long as you pick a valid number between there. Okay? So I'm picking 1. What do you know? If you put 1 in for x, x is positive. 1 minus 4 is negative. 1 plus 3 is positive. A positive times a negative times a positive.
Negative.
Well, the two positives are positive times a negative does make it negative. So this section of the graph is negative. Can you guess what the next section is going to be?
Positive.
You're seeing the trend, right? And it is a legitimate trend, okay? If we're just for formality's sake, a number bigger than 4, so if I test 5, 5 in for x is positive. 5 minus 4 is positive. 5 plus 3 is positive. Multiplying a whole bunch of positives is positive. Okay. Now, what's this mean? Okay. If the graph is negative to the left of -3, negative means it is where?
Starts.
It is below the x-axis, yes?
Yep.
Between -3 and 0, my graph is positive.
Yes.
So from -3 to 0, my graph is positive. From 0 to 4, my graph is negative. So from here over to here. And from 4 to the right, my graph is positive. Okay? We don't have any information like you did on the quiz about increasing or decreasing. It's going to tell us mins or maxes. This is the information we have. Can you connect this to make a curve?
Yep.
Yeah.
Okay? Because that's what we're doing here when we sketch this graph. Okay? Your curve has this shape. Now, another topic we could talk about here is the fact that if you multiplied these x's together, what would be my highest power in this problem? X to the third, yes, x cubed. Okay. I don't know how much you have memorized the end behavior chart, but x cubed is either down up or up down. This is positive times positive times positive, which would make it positive x to the third. So that means my graph would start down and end up. Well, if it's starting down and it has to hit all these zeros, you can also use that information. Okay? Questions here?
No.
Because this is kind of level 1, yes? Okay. This is level 1 because this equation provided was already factored. Okay?
Oh, that's so weird.
Okay. So, I have B on my next screen. You guys have what you need here? As we look at B, notice it starts off telling us to factor and then use the zeros to sketch the graph. Okay? In other words, does the process we just did, does that work with the equation as it is? It does not. Okay? So, similar to last time, I'm going to set my equation equal to 0. 4x to the third plus 4x squared minus 24x equals 0. Okay, guys. This is what, probably last unit, topic 2, factoring. Pull out those factoring skills.
I forgot.
What do you notice about all 3 terms?
They have an X.
They have an x and they have a 4, yes?
Yes. So you can divide it all by.
Okay. So think GCF. Okay. Think greatest common factor. 4, 4, and 24 all divided by 4. And x cubed, x squared, and x, they all have at least an x to the first. So factor out a 4x out front. If we have 4x cubed and we divide out 4x, we now have
X. Second.
x to the second.
X.
If you have 4x squared and you divide out 4x, you now have x. If you have minus 24x and you divide out 4x, minus 6. Okay? So I have 4x times x squared plus x minus 6. Keep going. How can I continue to factor?
3 and -2.
3 and negative 2, because he's talking about product and sum. You see it? Okay. So keep this 4x out front. Don't get rid of that 4x, because that represents one of my zeros. Okay. But x squared plus x minus 6, that's a typical quadratic. It's an x squared plus an x term plus a constant term, so we're hoping it factors. And if we're talking about finding zeros, it probably does factor. So we know x squared breaks into x and x, and product and sum, my numbers are multiplying to be negative 6 and adding to be the invisible 1. And so 3, 2 combo, since it multiplies to be negative, you got a positive and a negative. Since it adds to be positive, positive 3 minus 2. Okay. Hate to tell you guys, factoring has never gone in algebra. It's not gone in pre-calc or calc either. It's never gone. Okay. It's a part of your math life now. Okay. You tell me, what do I do now? Yeah, we're trying to find our zeros, so take each factor and set them equal to 0. We have 3 factors that we're saying equal to 0 here, don't we? So we're going to set 4x equals 0, x plus 3 equals 0, and x minus 2 equals 0. Okay, what do you know about 4x equals 0?
4x equals 0.
Okay. Officially, if it's 4 times x, we can divide by 4, and we get a 0 of, what is 0 divided by 4? 0. Okay. X plus 3 gives me the 0 of negative 3. X minus 2 gives me the 0 of positive 2. So I have zeros of 0, negative 3, and 2, which could all just be listed as with commas. I just kind of set them up how I had them. Okay. I'm going to talk number line again because I want us to practice that. Okay.
Is there another way to do it?
The other option would be looking, and it's a good option too, 4x cubed is my lead term, and think about in behavior. Like up and down and up and up, down and down. Okay? Part of me wants to just go that way, and I could, but I don't know, are we ready for that?
That seems like less work.
It seems like it is less work. Does it? I don't know. How do you guys feel about in behavior?
I don't care.
Okay. I'm torn here, can you tell?
I say we just take the cluster and just
I'm going to talk both, just to, and here's the deal. Can you get away with talking just the one?
yes.
You can. Okay? So, predict right now. If my lead term is 4x cubed, what kind of in behavior is that going to tell me? It's x to the third, which is either up and down or down and up. It's a positive 4x to the third, so that means what? It starts down and ends up. This section was somewhat successful on the quiz yesterday. Okay, so with that in mind, without doing any of the work that we're getting ready to do, what do you know about this section over here to the left of negative 3? If it starts down, it's going to be negative. Without doing any work, if this ends positive, what do we know over here? After 2, your graph is going to go up, so it is positive. Now, we'll talk about this more when we get a little bit farther into the lesson, But each of these factors just happen once. There's no squareds or cubes on any of the factors. So you can alternate and figure out that you're going to get there. So if this is negative, then
That's positive.
positive and
Negative.
negative. That is legitimate looking at end behavior. Okay? And quicker, isn't it? If you understand that. Okay? And I think a lot of you probably would prefer that option.
But then we wouldn't have to factor either, would we?
Nope, you'd still have to factor to have your
Yeah.
zeros. Yeah, you're going to have to factor no matter what. So, but what it saves you is all of the plugging in, yes? Okay? It saves you all the plugging in. But if you're plugging in values, over here you're testing something like -4, right? Let me at least do at least one or two of these to prove it. If I test -4, 4 times -4 is going to give me a 4 times -4 is going to give me a negative. -4 plus 3 is going to give me a negative. And -4 minus 2 is going to give me a negative. 3 negatives, when we multiply them together, is a negative. Is it matching up? It is matching up there, okay? And that was, I should have written this over here, plugging into 4x, x plus 3, and x minus 2. Can you test each of the sections that way? You can, okay? Here, I'll skip the middle two. What if I test something to the right of 2? What am I testing? If I test 3, 4 times 3 is a positive. 3 plus 3 is a positive. 3 minus 2 is a positive. Okay? Okay, here's my question. Have you sketched your graph yet? Make sure you give me at least some kind of numbers. I don't have to have all the numbers in, but I need some kind of numbers labeling me. Okay, what do I know? What's this graph have to touch? Has to touch 0, it has to touch -3, and it has to touch 2. Where's my graph starting? Starting negative, yes? Where's my graph ending?
Positive.
It's ending positive. Can you see what your pretty much your only option is in the middle?
Yeah.
It's going to have to go up, down, and back up. Does that match negative, positive, negative, positive?
Yes.
Below, above, below, above. Okay? So find the shortcuts or methods that work for you there. Okay? Questions there? Okay. Let's look at C. Same direction as the last time. Factor. Use the zeros to sketch its graph. So I'm going to take my graph, or my function, x to the fourth minus 81, and set it equal to 0. Factoring thoughts.
No.
You can do square.
Wait.
Is there GCF? Let me get that out of the way. No, x to the fourth has x's, but 81 doesn't have any x's. 81 has numbers. X to the fourth doesn't. Okay, no GCF other than 1. Okay. Patrick said something about square roots. Are these both squares?
Yeah.
Okay. This falls into the category of difference of squares. This is one of our identities on our pink paper. Difference of squares. This is also something I guess here's my thought. I'm going to erase this here in a moment, but what if you had to factor x squared minus 81?
Square root of x squared, square root of 81.
And that's something we've been doing, isn't it? I'm going to erase this in a moment because ours is a little different. But the square root of x squared is x. The square root of 81 is 9. How do you multiply again negative 81? Plus and minus. That's what we were doing earlier this school year, yes? That's what you did back in Algebra 1. Now, what changes? It's x to the fourth. Is x to the fourth still a perfect square?
Yes.
It is. What's the square root of x to the fourth?
X squared. Second.
X squared, right? In other words, 2 plus 2 equals 4. So x squared times x squared will give me x to the fourth. What's the square root of 81? 9 and 9. How do you multiply to get a negative 81?
And
A plus and a minus. Am I done factoring?
No, you got x squared. I don't know, you might be. Are we?
I don't know.
Either.
You had a tricky one like this back in lesson, I don't know, 3-1, 3-2, 3-3, somewhere in there. I don't remember where. But you had a tricky one. Wherever we did the polynomial identities. You had a tricky one like this. We're not done. This was a difference of squares, yes? Not both of them, but which one is a difference of squares? The x squared minus 9. Okay? X squared plus 9, it is in fact done. It does not factor any farther. Okay? Anytime it's the sum of squares, it does not factor any farther. Because here's the deal, guys. The reason this works is because my outside and inside terms will end up canceling out with the plus and the minus. With a plus 9, I'd have to have same signs. Either positives or negatives, and the middle terms will cancel. X squared minus 9, however, that's still a difference of squares. And in fact, without even thinking, oh no, I didn't quite do it. I did x squared minus 81. What's the square root of x squared? X. What's the square root of 9? 3. How do you multiply to get negative 9? Plus 3 minus 3? Okay. So that x squared plus 9 is going to stay. I can't factor that. We're going to be stuck with it. Okay? But we do have the x plus 3 and x minus 3. Okay. How do I continue to find my zeros? Set each piece equal to 0. X squared plus 9 equals 0. X plus 3 equals 0, and x minus 3 equals 0. Okay, what do you know? X squared plus 9 equals 0. How do you solve?
Subtract 9 over.
Subtract 9 over. So then I have x squared equals negative 9. How do you solve x squared equals negative 9?
Square root.
Okay. Our rule when you have x squared equals a number is to take the square root.
3i.
And? Okay. So square root of negative 9. Remember, square root of a negative results in an I, right? So the square root of 9 is 3. The square root of the negative 1 makes it 3i. When we take a square root in an equation setting, we need to tack on a plus or minus out front. So in this setting, the square root of negative 9 is positive 3i and negative 3i. We'll talk about those in a moment. Okay, get your other zeros. If it's x plus 3, we have a 0 at negative 3. And if it's x minus 3, we're going to have a 0 at positive 3. Okay. With that in mind, how many zeros did I just get?
4.
4, technically, yes? Now, have we talked in this class? I'm trying to remember if we've talked about it or if it's upcoming. This is x to the 4th. So should I have 4 zeros? Yes, I should. And I'm not sure if we've talked about that quite yet in here. I think I talked about it in pre-calc the other day. But this last one was x to the 3rd. How many zeros did I have? 3. This is x to the 4th. I should have 4. Now, when we think about a graph, or we think about testing this to see what our graph is going to do, what values do we have to think about here?
Negative 3i and positive 3i.
Where are those on a number line?
Far left, far right.
They're not. They're not real.
Okay. And here's the deal. We can put negative 3 and positive 3 on the number line. Can we put 3i and negative 3i on the number line? Not on a real number line. Okay? So, these are zeros, which means they are solutions to the equation. But are they going to actually be x-intercepts? No, because they are imaginary. So what are my only x-intercepts? Negative 3 and positive 3. Okay? And that's plus or minus 3i. We can't graph those. Now, you can do test values, or you can think in behavior. If we talk in behavior, highest power, lead term, is x to the 4th. X to the 4th. The 4th power is even. Okay, what do we know about even powers? What's the even power that you know real easily? You know the graph of x to the 2nd, yes. What's the graph of x to the 2nd? A parabola. What kind of in behavior does a parabola have? It goes up and up, or if it's negative, it goes down and down. This is a positive x to the 4th. What do you know about a positive x to the 4th? It's positive, and my in behavior is going to go up and up. And this is where I hesitate. Are we good enough with in behavior to do this? I don't know. Okay, and that's the thing. You will have the pink paper option. You can have that in homework. But up and up means what? What does that mean about the sections of this graph? Okay. As we look about that, if it's up and up, that means over here on the left, my graph is going to have to be positive, and over here on the right, my graph is going to have to be positive. What would make sense in the middle then?
Negative.
It's going to alternate and be negative. Now, you can also test it. So if you look at our factors, if I grab my factors were x squared plus 9, x plus 3, and x minus 3. Okay, if I pick a test value and, what's something to the left of negative 3? I could test negative 4. Well, work with me real quick. Negative 4, when I square it, it's going to be a positive, and add 9, it's going to be a positive. What about negative 4 plus 3? That's going to be a negative. What about negative 4 minus 3? That's going to be a negative. Negative times a negative is a positive, times another positive is a positive. Does it check? It does. What can you try in between negative 3 and 3? I'm gonna go for the easier route. Finally, it's the only time I get the option today. I'm gonna test 0. But 0 squared plus 9 is a positive. 0 plus 3 is a positive. 0 minus 3 is a negative. Positive times positive is positive times negative is a negative. And if you test something bigger than 3, so if I test 4, 4 squared is a positive. 16 plus 9, that's going to be a positive. 4 plus 3, positive. 4 minus 3. And all positives multiply to be a positive, yes? Okay. Have you graphed?
Yes.
What is... I cannot draw a straight line here. Jeesh. Okay, what do I need to put on this graph? Minimum, you have to have negative 3 and positive 3 on there, yes?
Yep.
Because those are my zeros. Plus 3i and negative 3i. I can't graph those. Okay? They're solutions, but they're not x-intercepts. Okay, what's this graph going to look like?
A parabola.
Basically a big old parabola, isn't it?
Yeah.
It starts up. It goes negative, and it ends up. Now, does this make sense? Positive, negative, positive. Okay.
Sure where the bottom line goes.
How low it goes?
Yes.
Nope. Does not matter how low or high your graph goes. And this is a sketch, okay? When we are sketching graphs, we don't know anything about heights. We just know about the shape and like where it goes left to right. Okay? Now, the fact that we were able to know that we were just alternating has to do with each of these factors was just happening one time. There was 1x plus 3, 1x minus 3, 1x squared plus 9. Okay? Each of these factors happened once. And that allowed us to know that you can just alternate. Once you know one, you can alternate. When we look at the next section, we start talking about something called multiplicity. And the idea of the multiplicity talks about what happens when you have powers here. Okay, this is x minus 1 to the 4th. So that means it's x minus 1, x minus 1, x minus 1, x minus 1. Okay, so these little exponents, they talk about the multiplicity. The multiplicity of a zero of a polynomial function is the number of times the related linear factor is repeated in the factored form. Multiplicity of a zero is determined by the power of the linear factor. Now, here's what we'll have to notice. If the multiplicity is odd, it does what we've been doing. Because all of our multiplicities have been 1 so far, and 1 is odd, so we just cross through the x-axis. The big key will be if the multiplicity is even, the graph simply touches the x-axis, but it doesn't go through there. So it's what we call a turning point, because your graph is going to approach the x-axis, hit that point, and turn around and go away. It's going to turn around and run the other way. And so, I guess tomorrow, we're going to talk about each of these and looking at the behavior of the graph and how we can use that to also sketch the graph. Okay? So, I guess tomorrow. And this is why I think I have that 3-5 took me 3 days to get through last year. Because we only did 3 examples today.
That is okay.
So, homework should be out there and available. You know how to do a little bit. You wouldn't know how to do very much yet. So.